TensorFlow is at the center of this conversation. All right, what can you do with it? TensorFlow is really about mathematics. You know, some of you may know what tensors are, right? This isn't a math class, which I guess it may very well be, because machine learning is essentially math. A lot of statistics, a lot of matrix algebra, etc. It is essentially math. So let me put that out there. And I guess that kind of gets to the point of what AI is in the first place. I mean, it's essentially mathematics. And if I was to define it for me personally, not getting into the textbook definition of AI or anything like that, AI for me is the ability to make quick decisions based on data. And you want that data to be quality data that you can extract features from, by which you can make useful predictions, right? We're not talking about abracadabra type predictions. We're talking about predictions based on data that has been manipulated, whether it's through pipelines, etc., into, like I said, a very useful structure by which these features can be extracted and then we can make useful predictions. Which, when you think about the decisions you make, just from a practical standpoint, a lot of times the decisions you make is based on your experience, right? So it's kind of the same way with artificial intelligence and machine learning. You're making these predictions based on the data that's available, right? And the ability of the model to take that data and get the most out of it. Because you could have the data and still can't make predictions, right? You got to be able to extract those features necessary, because that's where all the science and all the other stuff comes in, after that, which we won't be able to talk about today. So what does TensorFlow do? Like I said, TensorFlow is about mathematics, and there's a higher level API we call Keras, which allows us to build the models, right? Which in my case would typically be using Keras to build layers and using one of the Keras APIs, whether it's sequential API, functional API, the APIs, to actually build these models. And one day we'll actually go through an actual model with all the layers of nodes and things, but we don't have time for that right now. But essentially, when you think of models, you want to think about inputs and outputs. You're essentially talking about what I call kind of a pinball machine of, it's essentially in my mind, it's essentially a pinball machine. That's one of the best things best comparisons I can make for it. But like I said, one day we will create the layers, the input, the layers, and the output, just so you can see how these models look. And I guess it kind of lets you know why Keras is useful, because you can create these dense layers with code, and it just makes it easier for us to do. So once you've done what you need to do with the data, right? Because TensorFlow has something that I call TF data, right? Maybe you got experimental and you're taking some CSV data and you're bringing it into the system in order to do what you need to do with it to, like I said, be able to extract features from it by which you can create a model, train a model that can make useful predictions, right? And once you have that, you can deploy it, right? So that's what the Vertex AI is for, the ability to actually deploy the AI platform, right? This is TM data, right? So that's how you get your data. Once you get your data, then what happens, right? Then you can create your model. Like I said, Keras can help you with that. You can use, like I said, you can use a sequential API. All of these APIs have pros and cons, and you can create your model, etc. All right. So once you create that, what do you do with it? You can build it, and you can use compile, right? So we can get into some other things here. You got stuff like optimizers, right? Atom is one. You got your loss functions, right? Um, like mean square error. So you'll definitely see a lot of statistical jargon when you're talking about, you know, machine learning, you know, and they're right there together. The statistics, the mathematics, and the machine learning. It's right there together. And you might have some metrics here, but again, we're not going to get into all that. We're just trying to keep it, keep it at a nice level. So here you're building a model. All right. Then what? Once you build the model, then you want to train the model, right? So there's a way to do that, right? You can train it, right? Now, once you train it, then okay, you feel like you got something, then you could actually try to make some predictions, right? You don't want to overfit. You don't want to, you want to follow all the best practices so that you've done what you were supposed to do to get a model that can make predictions. That's really, at the end of the day, that's really what this is all about. Taking this data, creating a model, making useful predictions. Okay, I won't get into epics and all that. This is if you get this 1, 2, 3, I think you're good. Obviously, there's the fourth aspect of actually building the model. Okay, you have a model, you can save it. You can with TensorFlow, you can save it in a generic format that can be that's cross-platform, that can be used by a variety of external systems, right? You can also deploy it. Like I said, you have, if you're working on Google Cloud, you can deploy it. And they have an AI platform for that, right? So with that, you can upload and then deploy your model. It does take some time to do that, so be patient. But if your model is as good as you think it is, it'll be worth it. So you can upload and deploy it. So from there, you can get an endpoint, right? So you have a model, it can make predictions, you can deploy it. Next thing you know, you have an endpoint, and you can actually go into the Vertex AI console and see your endpoint, right? So from there, you can use that endpoint, because before you was using your model to make predictions. But you can also use once you get an endpoint, you can use your endpoint to also make predictions, right? Okay. I think you see where I'm going with this. So we've gone through this in about 10 minutes. Obviously, it takes, far much more time and energy in order to get a model that you can put in production, that has, everything you need to make those valuable predictions, to make predictions that are not harmful to the user, et cetera, et cetera, et cetera. I think you know where I'm going with this. So it takes a while. Sometimes it takes a lot of money to train the models and to get them where they need to be. But now it's, like I said, instead of just talking about AI, now you actually know how to do AI, how it looks. It requires the mind of a scientist, and you have to know the mathematics. Obviously, you have to know the tech. Like I said, I'm a Google Cloud guy. It doesn't have to be Vertex, AI. There's other options, but this is what I use. But it's a good place to stop. We'll talk later.